Good morning to my massive audience that I have speaking. If I wasn't nervous to begin with, less makes it more. So my name's Chris Rose. I am the Managing Director and co-founder of Cider Water. We are a company of one technology, but an incredible technology that enhances RO and desalination efficiency. A little bit about us and the history of the business. We're not the clever guys who invented our technology. We came across it in the marketplace in the US in 2018. And initially we were looking at as a solution for scale removal and prevention, which is where the majority of our experience lies as a business. We are, I suppose, we would describe ourselves as a clean tech innovator. Prevention and removal of scale. We'll come on to a few of the other applications. And yeah, as the mission statement says, sustainability through innovation and excellence. I love it when we have words like this on PowerPoint displays that I'm supposed to read out and describe, but yeah, our technology is steeped in innovation. We're a very small business. We only started in 2020. For anyone who's looking to start their own business, don't do it just before a global pandemic. It wasn't a great time to start. But in the short time that we have been doing it, we've developed a really good presence within the UK. We have good activity throughout Benelux, good distribution channels in Spain, and in predominantly North America, although we do some work down in South America. What are we? We're a water conditioning technology, and as I say, the history of it has been in scale prevention and removal. What is the technology? It's a pipe. And in our wonderful pipe, we have an anode and a cathode, and we have a lovely control box that you can see separately. So we're an inline electrochemical water restructuring solution. The purpose of the technology is to alter ionic behavior in the water. We don't take anything out of the water, we don't put anything into the water other than energy, we're just altering the ionic behavior within it. And we do that in order to disrupt the bonding that would otherwise occur. So going back to the core function of the technology, that is how we prevent but also remove existing limescale within systems. There's no chemicals within the system at all. There's no sacrificial media. We don't have anodes that are sacrificial over time. And to date, the technology has been proved industry-wide throughout hotel-based customers, through gym chains that we do throughout Europe. We're rolling out to 1,600 sites to a gym chain throughout Europe at the moment. Big applications in heating and cooling, where obviously limescale is prolific. Over the last couple of years, we've got more and more into RO and desalination, driven by demand from our customers. So the restructuring effects of the water have been seen huge benefits in RO systems, in particular with desal. Covering off some of the more traditional aspects of the technology, I've mentioned it one or two times. We prevent and remove limescale. We also reduce corrosion. Nobody could say that they could completely inhibit corrosion. We offer a significant benefit in that area. Water quality and water hygiene has been a huge thing to our customer base. When we first started working with Marriott Hotels, one of the things they said to us was, great, you're going to prevent and remove limescale in our systems. That'll help us with Legionella control. And we were pushing back from it. We don't do anything to kill waterborne bacteria. We're not a chemical treatment or anything else. But what we are doing is removing the breeding ground from the water. By removing limescale from the system, we're lessening the resulting biofilm that would harbour waterborne bacteria. So we're a secondary control measure. Massive application for the technology is undoubtedly energy efficiency. Where you remove limescale from a heat transfer surface, you improve the efficiency of the heat transfer, and therefore you reduce the energy consumption. So there are countless examples of that, from traditional things like chlorifiers and plate heat exchangers to heat pumps to whatever that heat source is. And now, as we go on to talk about now, for the purposes of this show, certainly improving the filtration efficiency. What are the challenges, or what are we doing rather in terms of RO and desal? Preventing scaling before the membranes. By that we mean that our unit is placed in line before membranes within a system, typically upstream of the high pressure pump. In doing so, we reduce the scaling on the membrane surface. We also help with removing any that may be there. That in turn, of course, is helping improve flux stability and membrane permeability. We enhance permeate quality. The recent studies that we did, which I'll come on to with Cranfield University, showed a dramatic reduction in ion passage, in particular with chlorides and sulfates. So cleaning up the permeate water has been a big thing for us. Of course, where you stop scaling and resulting biofouling on membranes, we're extending the life of those membranes. And the big thing, of course, for everybody in desal is reducing energy consumption. By improving permeability, we are directly reducing kilowatt hours per cube of permeate produced. Desalination challenges, I don't imagine I need to run through these. I think we're probably all aware of what they may be. Scaling and fouling, of course, and the extended energy use. People do increasingly want to reduce anti-scalant use where they can. Less cleaning cycles, of course. Our message is we're offering a chemical-free alternative. Cranfield University in the UK have been a great partner from us from the beginning. Indeed, actually, when we were considering the purchase of our technology back in 2018 and we were reviewing the IP, it was Cranfield University that we went to. I am not a chemist, nor is my business partner. What we wanted to do was say, okay, what is this incredible technology that we're looking at, that we're thinking of developing out there within the marketplace? So Cranfield have been a great partner with us from the get-go. The independent trials that we ran with them over the summer period for 3 months showed marked improvements in permeability, significant reductions in ion passage, and very specifically a lower rate of flux decline. I would get into all of that today, but then I wouldn't have anything to talk about tomorrow. I'm speaking over in one of the other halls, so please come and see me in conference room A tomorrow, where we're going to get right into the detail of that Cranfield study and some of the specific numbers that we saw there. In terms of where we are as a business, if you were coming to us today and we were talking about what we do with scale prevention and removal, we're all over it. We've done it for thousands of customers in multiple different countries, and we understand exactly what the technology does there. When it comes to RO and desal, we're at a slightly earlier stage. What we've seen in every single instance where our technology is used, we have significant improvements in efficiency in multiple areas. But we're going through the process of quantifying that through various partners, channel partners and academic partners. This was a really interesting one for me when a membrane manufacturer had come to us to say in northern parts of the Netherlands they're actually not permitted at all to use anti-scalants. So they wanted to find a solution to maintain RO performance and reduce the changing cycle of the membranes. They did 3 stages to the trial. They ran from a control point of view using just the RO with no anti-scalant and without our technology. They then ran exactly the same mechanism with 100% recommended dose of anti-scalant, and then they ran just with the Integro in place. What we saw from that was an increase in recovery rate of about 5%, so a really marked increase in recovery rate. But the very interesting thing about it for us was, although we weren't successful in preventing all of the scale formation on the membrane surface that the chemical descalant did, we still maintained the same 90% recovery rate, the improved performance of the membrane, but with a small amount of scaling on the membrane surface. Going back to the first slide, where in a very cheesy way everybody talks about environmental benefits and sustainability, because of course that is a hugely important part of what we're all trying to achieve. For us it's very real world though. Every instance of our technology going in is having measurable benefits in chemical reduction, in reduction of energy consumption through improved recovery rates, and of course very much aligning with sustainability goals that people are trying to achieve. We popped this one in here just because it's really interesting for us. This is some trials that are being done through a major water treatment partner. They're a Dutch-based manufacturer of RO systems, significant presence in the UK, where as you will have gathered I am from. And this is a very, very small system, and it's not desal, it's fresh water, so forgive me for putting it in for the show. But what was very interesting about it was it demonstrated just how quickly people see results. These results were taken less than 2 weeks after installation, where we saw an increase of approximately 20% in the production of permeate on the system. We saw an increase again in recovery rate of about 4% and a reduction in rejection rate. Once again, the really interesting part for us was, and the most important part for them, is there was an improvement in the quality of the permeate water. Once again, ion passage had been significantly reduced. For them, the trial continues. Now they're looking at, do they carry on at the same pressure they're at with a higher rate of permeate production, or do they throttle that back and trim the pressure in order to lower the energy consumption per cubic metre of permeate? But yeah, it was a really, really interesting one for us, but we're monitoring that closely. I'm embarrassed to say that this is a technical summary for a technical audience, but a layman's technical summary. What are we doing from a technical perspective? It's electron injection, and we're trying to alter the ionic behaviour of in particular scale-forming minerals or salts that are in the water. Crucially for filtration though, what we're also doing is breaking hydrogen bonding within the water clusters, giving a direct increase in permeability. Disrupting scale nucleation or scale formation, very much compatible with anti-scalants. I don't stand on this stage with a mission to replace anti-scalant use completely. We'll never achieve that, or it's unlikely we'll ever achieve that. But we can help significantly reduce the amount that's there and work in harmony. With no moving parts, there's no scheduled maintenance on our solution, of course, like any other system. Things go wrong, things might need to be fixed, but it's a very, very sustainable piece. And on that note, very proudly from a European point of view, we manufacture all of our equipment in the UK, proud members of Made in Britain. So from an environmental and an operational impact perspective, once again, chemical-free pre-treatment, fewer cleans and longer membrane life. We haven't managed to quantify that as much as I would like. I love numbers, love data, love R&D, it's what makes me tick. We haven't, because of course we've only been doing it for a short period of time, managed to get concrete data on exactly how much we're extending membrane life by, but early membrane autopsies have given us some really, really good indications and good data. We help lower OPEX and carbon footprint, and of course we're supporting net zero goals. Takeaways from the talk, from our side of things, it's an independently validated piece of technology. Early stages, but independently validated with different research partners, both in the UK and in the US. What are we doing? Cleaner permeate water, higher recovery rates, and crucially, lower energy consumption and lower chemical use. We throw this in just to brag a little bit because we're very proud of it. XPRIZE and their Water Scarcity Challenge, one of the tracks that they're on. We entered as track B. I'm not sure whether you're familiar with the competition, but track B, where we have, it's the novel materials side or a novel part of the process. And out of the hundreds of initial applications that came in, we have got to the qualified stages in the track B competition. So really, really proud of the achievement. There's some real interest in what we're doing. And we hope over the next 12 months to get significantly further with it. But yeah, very, very happy with it. Thank you very much indeed for listening. We are also exhibiting. We're at the far end of the hall up next to the delegate dining zone. We're on a stand there, so please do come and visit the stand. The Cranfield University part of the talk and the results from that I'll be sharing during the talk that I give in May, I think it is, tomorrow afternoon. So hopefully see some of your faces there, and yeah, delighted to answer any questions that you've got.